So again, welcome to the March Arley's Irvine meeting on sports statistics, advancing your career in 2020 and our adoption in the enterprise. Welcome. I can't emphasize that enough. Whether you're an R novice or R expert, this group is for you. Everyone is welcome regardless of gender as long as they follow the Our Ladies Global Code of Conduct. So Our Ladies, I love to go over the Our Ladies Global mission every meeting just to keep it in our mind. It's a worldwide organization that promotes gender diversity in the art community via meetups and mentorship in a friendly and safe environment. That means that we follow our code of conduct closely. We answer all questions, regardless of your background. Like, no question is a stupid question. And if you want to ask a question during this meetup, feel free to type it in the chat and I'll do my best to get to it as soon as possible. So we also like to take a minute to thank all our sponsors, both global and local. So our global sponsors are the ARC Consortium, our studio, our Forwards, and the NASA DataNauts program. Our local sponsors and friends are the Microsoft Developer Advocates Program, PeopleSpace, Edwards Life Sciences, OC Rug, and UCI and the UCI Data Science Initiative. So our first announcement is that we have recently built a new Arley's Irvine website, recently as in like in the past 3 or 4 months or so. And we've added links to all of our social media, including our Meetup, our Twitter, our email, GitHub, and YouTube channel. We've also added all of our sponsors and a blog. And if you would like to contribute to the blog, whether it's like anything related to learning R or like anything related to going to your first conference, any kind of professional accomplishment that's related to R, we'd love to hear from you and we'd love to publish it on our blog. Our next set of announcements is related to upcoming volunteer opportunities. So the Orange County Science and Engineering Fair is going to be next week online. Normally it's held at the OC Fair and Events Center, but due to the recent conflict, they will be holding it online, and they're looking for volunteer judges. So if you work in any area of science or are an educator, they'd love to have you. Madeline, one of our co-organizers, recently gave me a flyer that I'm going to show. So here it is. Basically, yeah, it's telling you the same thing that I told you. And this flyer is also on our GitHub. Volunteer judges needed for next week for the Orange County Science and Engineering Fair that's online. So the next items are the Chapman University and UCLA Data Fests. There's also a Cal Poly SLO Data Fest, but that's up in the air. And these 3 data fests, Malin also provided flyers on those. They've been suspended, but they might be moved online, and they will potentially be exploring and examining COVID-19 data. Yeah, so that would be constructive. And then I saw something pop up in the chat. Okay. So for the Orange County Science and Engineering Fair, they mainly need judges in biomedicine and molecular biology. Thank you, Madeline. Okay, and then the next announcement is that the International Science and Engineering Fair for now is being held May 12th and 13th, 2020 at the Anaheim Convention Center. And they're also looking for judges and in general in any type of academic field. But also the statistics area is looking for people who know a lot about statistics and who can assign a special statistics award. And again, Madeline has provided a flyer for that. All of these flyers, not just the first, are on our Ladies Irvine GitHub and will be sent out after the meeting. So yeah, this shows that there's ASA Special Awards in Statistics. And then next year's Science and Engineering Fair, pending everything going well, will be held in May at the Los Angeles Convention Center. So that's really lucky of us in Southern California that the Science and Engineering Fair will be held twice in 2 years in a row in Southern California. So I'm just looking at the chat. Okay, so moving forward. Um, our next meeting will be held in May. Our meetings are every other month, and we have a speaker scheduled who will talk about R and GIS and how to work with GIS data in R. So that will be really, really interesting, really helpful to a lot of us. So it's going to be either at UC Irvine or online, but it's looking like it's going to most likely be online. And it's going to be Tuesday, May 19th at the same time as this meeting, 6:30 to 8:30 p.m. Okay, every meeting we love to highlight a notable woman in STEM. And I'm going to get to your questions after this slide. So this meeting, we decided to highlight Katherine Johnson, the NACA and NASA mathematician who was featured in the 2016 film Hidden Figures. She recently passed away, but all of her calculations and contributions to science and NASA have lived on and will live on for a very long time. She worked for 35 years at NASA and its predecessor, NACA, and they were critical to the success of the first crewed US space flights, Mercury, Gemini, Apollo, the Friendship 7 flight, and the Space Shuttle program, and even the current Mars rovers programs. She was one of the first African-American women to work as a NASA scientist, and her accolades include the Presidential Medal of Freedom from former President Obama and the Congressional Gold Medal. So we always love to highlight notable women in STEM as inspirations for us. Okay, and so that moves us into our first talk by Louis Columbus on advancing your career in 2020 in R adoption in the enterprise. So without further ado, here is Louis Columbus. Louis, feel free to share your screen.
Thanks very much. Can you all hear me now? Hello? Okay, great. Okay. All right. So, trying to be considerate previously by turning off mute. So, to begin with, especially your career in 2020 and our adoption in the enterprise, the current situation we find ourselves in, it's pretty, it can freeze you with fear, and that can really crush your career growth prospects. But instead of allowing this situation right now to crush you with fear, you start to look at it from the perspective of what do you have that's so unique to offer in the world that you could produce content around it. And let me get right to the point. Everybody on this call has got math skills, or you wouldn't be on this call. And you have exceptional ability to generate data. There is a gaping hole in the world right now of fact-based data blogging and journalism. There is a big gaping hole because everybody is, wanting to share their own personal opinions, but there's very much of a gap in how data is interpreted. And so the world needs to hear what you have to say about data and about how do you build your own persona and your own reputation. And so instead of being frozen with fear, getting up every morning and thinking, oh my God, how am I going to get a job in this environment? What I really encourage you to do is pick the medium that best fits you, like it's video or it's writing or any other medium, and start creating. And the best way to work your way through, I think, this very anxious time globally is to create something and just keep creating and try to create something every day. At least make steps to create content every day, fact-based content, interesting content, data-driven content. Because I can tell you, I started a blog in 2010 and I started aggregating data together, and I felt most comfortable around data because I felt it was unequivocal, and I didn't feel like my opinions were any different than anyone else, but I knew data was unequivocally valuable. So I started writing very data-centric blogs, and I wrote on my own blog for about 2 years, and then I contacted Forbes, and I got on Forbes, and I've been there for about 9 years now. But I can tell you, in that journey of blogging and now getting in this mindset of producing content, it's done wonders for my career. And when I chose to leave Ingram, where I ran global cloud product management, I have about 50 people under me at Ingram. I hired a lot of people with analytics skills, but what got me in the door at Ingram was the fact that I was writing about product management, and I was writing a lot. And that really opened up a door. And then when Ingram chose to relocate a lot of positions either to Russia or into Europe, which I was not interested in going to either place. I want to stay here in Southern California. It opened up a door to go to Dassault Systems because they were seeing the blogging and the writing I was doing. And I got an interview with the CEO. The chemistry with the CEO was great. He already kind of felt like he knew me from the writing, and I was hired. And so I'm not saying that to brag. I'm saying that because blogging and writing is extremely powerful when it's backed up with data. And all of you have a data skill. So if you're worried about applying for jobs right now, shift your mindset and think about, what can I do to create excellent content that will define me for the foreseeable future, for years? And that's the best way to work through economic uncertain times. Because when you do show up to an interview, and when the quarantines do lift and we're beyond this pandemic, and we will be beyond this pandemic. I mean, all of us have, I think, an understanding of stats. I mean, yes, this curve is going to run. It's a matter of how long. But when that curve is done, then you'll have a very strong portfolio to walk in with. And I can tell you, as a hiring manager, and hiring people, I've hired many people in my career, people who can write technically, I will snap up. I mean, I definitely hire them because this is something that everybody looks around in, like a marketing team, product management team, executive team, and there'll be brainstorming sessions, and then it'll come down to, okay, who's going to produce it? And if you're the person that they turn to do that, you'll have job security and you'll be able to grow with that. Now, at Forbes, they do a lot of training and a lot of testing and of data, and they're really big into data journalism. And so they have a partnership with Google, and so a lot of these links here, which will be available on the GitHub site, you can use these, sign up for the News Initiative. I really encourage you to start thinking of yourself as a creator, as a data creator. And everybody's a data consumer, but if you're a data creator, that's just one more skill set that you can sell on top of all your programming skills. And even if you write about programming, it's a great way to prove you know what you're doing, and it creates great credibility for you. So looking at data journalism, here's a couple of great sites as well. Here's one from MIT that's excellent. There's a lot of great links there, and over here, data journalism tools. And the reason I'm enunciating so much on this and emphasizing this is that in these times, sitting at home under quarantine, it's very, very satisfied to generate something that you know about. And writing what you know about is probably the best way to alleviate the anxiety that is out there in the world, but it's also going to do a tremendous thing for your career. And then when you go to apply for jobs, you list everything you publish, even if it's on your own blog, just list it. And over time, your blog will get a reputation and people will start asking you to guest blog other places. So it's what you create, it's what you give that is going to differentiate you. So I really encourage you to do that. And there are many, many other ways of looking for jobs, at this during this time. But the best thing, the most solid advice I could say is become somebody who could actually generate content. Okay. Can they see it now?
No. Try to go exit out of that, and then.
Okay. So there, and can you see that?
Yes.
Okay. So yeah, what I'm just continuing to drive the point home is that looking at advancing your career overall with data journalism, you have to think of yourself as a creator. It's a great way to alleviate stress, and it's a great way to differentiate yourself in the job market, because so many people have technical skills and programming skills, but the ability to translate it into written content. And you also are filling a void in the industry of data-driven content. Not a lot of it out there. It's an instant way to differentiate yourself and show your value to an employer. It also shows initiative, which employers love. Another aspect of advancing your career, another great way to burn through the stress of this whole quarantine situation, is to think about getting a certification and being able to choose the one that aligns greatest with your strengths. And this is from an article I wrote on Forbes that talks about the top IT certifications from Global Knowledge last month. And this is by far the most valuable content that they see Global Knowledge does. Global Knowledge does provide some services for this, but this is another way to differentiate yourself. I spent a lot of time consulting with some AI companies in the Bay Area about AI-driven human resource systems. And so I'm on an advisory board with one of these startups, and on the advisory board are chief human resource officers from around Silicon Valley and from around tech. And so they're all talking one time, and I had to present on AI's implementation in high tech because I come out of that industry, and everybody was saying, I really want people who have this desire to learn and relearn and re-engineer themselves. And so when it came to certifications, they said that certifications, and this is like the CHRO of Visa was there. Huggy Rao, a professor at Stanford, was there. I mean, there was the former CIO and chief human resource officer of Google were there. So these are all people who have hired, collectively thousands of people. And the one thing that came out of that whole discussion is that they're looking for people that have initiative to reinvent themselves, to learn and relearn. And so wherever you are in your career, showing evidence of that you're constantly learning, that you're constantly involved in a learning program, that's another positive for you. That's another way to differentiate yourself. And that's another way to stand beyond people who walk in and say, please just give me a job. When you have that initiative of getting a certification, it's really saying, I continually am taking responsibility for building my own, building my own career. And so that's really important. Being a creator, being a learner is really, really important. And even now with all this downtime, it's a great time to get started. And also it'll burn through the stress, which is good. So, switching gears now into why R gets adopted in the enterprise. I spent a lot of time with personas or these roles in the enterprise. My job is to generate data that helps these people. So I can tell you that R has an extremely bright future because the questions that each one of these people get asked, from the CEO all the way down to the VP of sales, they're really complex questions. And it's really difficult to parse this data with Excel. There are some amazing Excel wizards out there, but they can't get to what R can do. So let me give you an example. CEOs want to be able to, our CEO wants to know how operations of expanding our partner strategy in Europe with a cloud-based ERP system, what is the implications on our financials and how is that progressing? And so R in the enterprise is being able to take that multidimensional question and factor it by adoption rate for cloud-based enterprise systems. And also to get a velocity rate of adoption. The other thing that R does extremely well, which you all know, with ggplot and other apps, is the ability to visualize. So a CEO reports to the board. The board of directors is their boss. And so they need to go in there and have really tight, excellent data that's visually oriented to get the board on, to support them in their direction. So, this is a very visually oriented, real-time data-driven world that a CEO lives in. The time horizon for a CEO could span from, quarter after quarter, but mostly when a CEO needs data, especially coming out of marketing, they need it in real time. So they basically want a new metric added to their dashboard, or they're trying to, work with the board to be able to invest in new initiatives to bring more partners on board, or to better serve customers with a product line extension. So that is one persona. That's one customer. These are all customers of R. The VP of channel strategy, you'd be amazed at how many different records there are, different sources of partner commerce, or in the channel, what is going on with customers. And R is able to slice through all that and create one single unified record of everything going on with channel partners. And the VP of channel strategy really needs R to understand price elasticity and the impact of promotions and rebate management, price controls. And now, given the fact that the economy is starting to slow down, pricing elasticity and price management is going to be what everybody's going to be after. And so more and more R programmers that work in the enterprise are going to really become experts on pricing. Price optimization is something that you could do with R. The alternative for price optimization with R is to go out and partner with SAP and spend hundreds of thousands of dollars on software to do that when R can do that already, and with someone with the skill set. VP of marketing is really concerned about which programs are the most effective, generating leads, campaign execution, knowing what is truly going on with pricing bundles, and also what's going on with customers. So we're doing a survey right now, and I'm working in conjunction with our CMO and CEO about a survey of 500 manufacturers. And what we're trying to figure out is, what are the coping mechanisms for COVID-19, and what are those coping mechanisms, and what are the implications on productivity in terms of manufacturing, and what can we share with other customers? So we're trying to create a community by learning these things and using R to communicate that visually as well as to parse the data and try to figure out what is most effective in terms of a marketing program. R will get more and more used and will become more and more of a key requirement in positions going forward as a result of that, in conjunction with Python, in conjunction with all these other tools. And R doesn't exist on its own in the enterprise. It is more of it's part of a tool set. And if you have expertise in R and you're looking for a job, it's great to be able to write about that on a blog and just get into this cadence of generating, a post a week, or, but having a cadence of that, because that's building an overall portfolio that you can walk into. And if you're responding to a job, you can say, yeah, go look at my blog, and there's a link, and it's tremendous in terms of marketing yourself. And then the VP of Sales is needing R badly right now to be able to manage best and worst rep performance in an uncertain environment. They all have, of course, a general rule, and a lot of it's done in Excel, and there are systems that can figure that out. But R is being used more and more to try to figure out what are the nuanced differences between the highest and lowest achievers and why. And because the VP of Sales right now in so many companies is a coach, and they're trying to coach their underperforming reps to have the same capabilities and the same attributes as their top performing reps. And that's where R comes in. R gives them the profile or the roadmap to do that. In terms of R getting adopted in the enterprise, the reason I included this slide, and this is out of the Stack Overflow survey. I really like this slide because it shows you how valuable these skill sets are in their clusters of overall marketability. So if you look at this and you think this is primarily a technology-driven map of the interrelationships of frameworks, but if you look at the clustering of this as a reflection of market potential of these skills, you start to see why having a strong toolbox of these skills is so important. SQL Server, I didn't circle it, but you can see that's pretty much of a go-to type of skill set. Everybody expects you to have SQL Server if you walk into an enterprise and apply for a job. Python's pretty much a standard. RStudio, not everybody knows it, but if you know it and you have the ability, and again, you point back to your portfolio and say, here's some of the best visualizations I've done, that's really powerful because it immediately gets beyond the programming actual tests that some employers do to test that overall capability, but it also shows initiative. And it's really important to show initiative in this environment to show that continually building out that content flow that comes from your core strengths. This is a Stack Overflow analysis I did earlier today using their trending app, and you can see Python questions are trending way up. Java is stabilizing, and then SQL is always been stable, and R continues to go up in relative terms. This is a pretty accurate picture of the skill sets that, quite frankly, we need at Dassault Systems, and that I've heard throughout the consulting that I do, some AI startups. These are all things that they talk about. What's so critical about being conversant in these is it's really fascinating and just so exciting to be around AI startups because they'll actually whiteboard something in the morning, and by the afternoon they have a prototype running because they'll use a variety of these different tools. And I love going to hackathons because I love to watch this happen. And being conversant in all these tools gives you the ability to jump right into a hackathon, contribute, and continue to grow your career that way. In fast-moving startups, this is absolutely must-have skill sets, and in the enterprise as well. There's still data on skill density. Skill density is really, really important in an enterprise. You can see that the big blue line for our data scientists. This comes from Jeff Hale's analysis that was done in January this year. Excellent analysis where he scraped on simply how to need a monster and on the data analyst term, and it shows what I like to call palette density or skills density. Again, having that skill set building that skill set, getting certified in that skill set, and then writing about it, I keep on coming back to that because that's proof. And that will immediately get you through interview cycles so much faster than having to go through and get tested and all those kind of things. And they'll take you, many people, of course, give you take-home tests and that sort of thing to look at your overall ability to code. Tableau is a really big deal in the enterprise. And I know sometimes technical people look down their nose a little bit at Tableau, but it is the bling of C-level executives. Tableau is definitely the bling of a C-level executive, especially in financial services and large manufacturers. Places like BMW, Merck, Ford, Chrysler. Even Mercedes-Benz and Daimler-Benz. The executives have flat panel, tablets that they do meetings with, and Tableau. They're Tableau powered with maybe R-crunch data, and that's how they make decisions. And it is definitely bling. So it's what everybody wants at that level. So having that ability to intersperse across the skill sets is absolutely critical. So with that, that is the overall presentation that I had for today. I probably went in a different direction you expected up here, but I can tell you hiring is going to get competitive, even more competitive now. And the only way to stand out is to be a creator and to show that you have the ability to learn and relearn. And that really comes down to pursuing certifications, even going through LinkedIn Learning. But showing that initiative and that ability to be a creator is going to give you a leg up on anybody you compete with to get a job, because technically writing data is so difficult to find, so hard. But being able to show that is really going to help a lot. Have any questions? Okay. I think the best way to improve writing skills is to, first of all, use Grammarly. It helps. I think also find a friend that you can trust and write something and ask them what they thought of it. But just write, just publish, and just, start a blog and just start publishing, and you'll learn over time. Also write. There's a real dichotomy between the UK and the United States when it comes to technical writing. Okay, in the UK they love narrative text, big long blocks. The United States is all about brevity and bulleted, text. If you're more comfortable writing bullets, saying this is my data finding, and then bulleting it out, and then just maybe writing a couple hundred words, that's great. But always remember that the golden rule is you have to respect the reader's time and always think about how can I best serve the reader, and how can I respect their time? And brevity is a beautiful thing, So if you think you can trim it and use a lot of data and a lot of graphics, I use a lot of graphics in my Forbes columns because readers, first of all, they really like it. I noticed that it gets shared more, but also in the one that I wrote last night about how COVID-19 is going to impact IT spending, a good friend of mine, Frank Scavo, works in computer economics, and he built a data table. It's called a Harvey chart, and it's like a Consumer Reports chart, but that kind of thing really works. And I think just continue to go after when you become an industry analyst. I'm a former industry analyst, so when you go through training. They train you to write in short, terse bullets and respect the reader's time. It's real important to do that, but just do it, and that's the way you'll find out.
Okay, thank you so much, Louis, for your presentation. It was excellent. I'm going to share my screen again. Okay, now we're going to have about a 10-minute break. We're going to come back, we're going to come back at around 7:45. And then we're going to have another guest speaker, Jason Wilson, Dr. Jason Wilson, I'm sorry, give a presentation on a sports statistics show and tell. So feel free to take the next 10 minutes to take care of your personal business. And we're looking forward to seeing you again in about 10 minutes at 7:45. Okay. All right, everyone. I hope you had a great break. And without further ado, here's a sports statistics show and tell with Dr. Jason Wilson. Dr. Wilson, you're free to share your screen.
Okay, can you hear me?
Yep.
Fantastic. Okay, well, thank you, Alyssa. Thank you, Madeline, for the invitation. Thank you all. Wish I could have been here or there in person to meet all of you and mingle. Great to be with you here tonight. So I've entitled this a Sports Statistics Show and Tell. And the way that I'm going to do the presentation tonight is kind of in three parts. I've got a story. It'll take about 15 minutes or so for that, questions following. Then I'm going to talk about results of our statistical work, and that'll be kind of the math stats part. We'll take questions after that, and then I'm going to move into some R scripts and just show you a few things with the data files that and the R scripts that I provided. Take questions after that. So, so without further ado, here we go. Just want to acknowledge my student, Jarvis Greiner, whose idea this was originally, his pitching coach, John Verhoeven, and my current collaborator, Wayne Greiner. All right, so table of contents, I kind of gave you guys the table of contents previously there. So this is a picture of my student Jarvis back in 2010. He was an undergrad in my Biola University Intro to Prob and Stats class, where I assign all students to do a project. Okay, so for Jarvis's project, he was a pitcher on the baseball team, and he was also a film major. So he conceptualized what makes a great curveball, and not only what makes a great curveball, but in contrast to fastballs, where there's a clear measurement miles per hour. And so just to give you an idea of a curveball here, notice how this pitch is going forward and then it has a sharp drop at the end. That's a curveball. I always thought a curveball moved right to left. That's a slider. The curveball goes sharp down. And so he was thinking of, in terms of curveballs, how can you measure that? Because speed is not what you're after. And so he set up 3 cameras in the production center, different angles, and he put tape measure up on the sides, and he did a freeze frame to collect a data set of what he thought would be the relevant variables to assess the quality of a curveball. And so the first variable out the gate, you've got the pitch starts, and it may go up. In a curveball, you throw the ball over your trigger finger, and that may make the ball rise. That's a tell, which is against your curveball. Next is how far it goes out until it breaks. It's the breaking point. The further out, the better. Next is the total vertical break. The more, the better. Finally, you have the location. And at this stage of the research, he was just going for the knee, which is the bottom of the strike zone. Okay, and I'm just going to leave it at that. This is the data set that he collected. So this is low tech, but this is really good stuff for 2010. And there it is. I guided him on a multiple regression model, and here's the model that came out. The coefficients are as we had expected. But what stood out was the model quality with high adjusted R squared and statistical significance of all of the coefficients. There were no quadratic terms. There were no two-way interaction terms. It was just a nice, clean model. So I wrote that thing up for publication, and after some adventures with the editors, got it published in this edition of Chance magazine. After publication, Jarvis's dad kind of stepped in, and he asked the question. He said, if my company, Griner Agencies, puts up the money for the patent, can you extend this statistic to all MLB pitches? Well, that was an interesting thing. And so Jarvis and I worked on this. And first, we discovered that in 2008, there was a 3-camera system put into Major League Baseball stadiums, not entirely unlike the cameras that Jarvis had set up in the production studio. And they had been collecting data. So it turns out that there's some work to do to decode that data in order to pull a trajectory out. But I did that work. And then I worked with Jarvis to extend the model. Most notably, we added horizontal break, and we added an improved location. So we moved from a one-dimension, just vertical at the knee, to a regular 2-dimensional strike zone. Okay, so the trajectory and location is what we called initially the Griner index. And that's what we had named the statistic for measuring curveballs in the Chance magazine. And then we added speed, because we had that also from this PitchFX data. Together, we combined those, again, using linear regression to develop a quality of pitch statistic. Okay, it's important to note, I didn't mention this in the Griner index. The response variable that we're mapping to is not the results of a hit, but they are the expert rating of the pitching coach. John Verhoeven was our key person for that part. Okay, this is the location concept diagram. The target is the corners, so closer to the corners, the better. Okay, I think that's the key details for the extended model. Now, this is just a little bit about what we came up with then. This is Clayton Kershaw, famous Dodgers pitcher, and he's pitching a fastball here. And you see that it's right in the middle of the strike zone. So that's not so great. And our statistic is roughly on a 0 to 10 scale, and that's a 2.96. It's below the 4.5 Major League Baseball average. Here's another pitch. And notice that this curveball just drops right down into the lower corner for a strike. It's got a nice late break, and so that rate's high on our scale at 8.09. Okay, this pitch you can see is way outside the strike zone as the pitcher's pitching, and so that that poor location takes it below 0 to a negative 2.49 on our scale. So hopefully that gives you a little feel for how this thing is working. Now, the second part of the story is that we were able to successfully complete the extension to Major League Baseball. We were accepted to present at the Sabre Analytics Conference in 2015. And we did that presentation. And here's a key piece for all of you who are graduate students and aspiring to move from academia into another discipline. We gave a 20-minute down to the second tight presentation, very practiced and rehearsed, a lot of interesting stuff in there. And at the end, it was mostly crickets. There was one substantial quote. Afterwards, had one statistician come up and ask us some stats questions, but there was nothing coming from the Major League Baseball industry. It come to turn out, at the end of the meeting, like the last day, there was a chance encounter with one of the analysts from the Brewers. And he deliberated whether he should even talk to me. And I could see that he finally just made a decision. He said, okay, I'll give you 15 minutes of my time. And he proceeded to tell me how all the analysts for the teams in the West were there. And they were very interested in our presentation, but they are 30 different black boxes. There's 30 Major League Baseball teams, all competing against one another. And a public statistic that's solving a problem like they're working on is not of interest to them because it offers no competitive advantage. That took the wind out of our sails. We were hoping for, a free exchange of ideas and really hashing this thing out. And it was a different world. The next year we went with an approach to network and achieve some validation from MLB teams, because that was the only way we would be able to get any traction with our statistic according to the different vendors and parties that we had approached with our statistic. So we presented a customized report like this one, which included a rank ordering of the pitching roster of 15 Major League Baseball teams, ranked according to the quality of pitch averages for the previous season. 13 out of the 15 teams said that, yeah, that pretty much kind of nails us. 2 of them did not, and they described how their basic pitching model is different than our quality of pitch statistic, particularly the location. And so they didn't match them. We felt validated, and ever since then we have been on a quest to kind of build this thing up and do some interesting work in the Major League Baseball arena. So that's the story for how it came about, and I think that was probably about 10 minutes or about 15 minutes there, Alyssa. So I'm just going to pause for any questions on the story part. Happy to fill in some details there if anybody's interested.
I haven't noticed any questions on the chat. If you have any questions, please enter them in the chat now, or if you don't have any questions. Oh, Madeline just asked, does left versus right-hand pitchers matter in your score? That's a great question.
Yeah, great question. So our statistic is context independent and batter independent. So it is simply measuring those 6 components that I described. Now, what we've attempted to do with that is offer a measuring stick that can be used to measure then left-handed versus right-handed pitching, or how that fares versus left and right-handed batters, or how pitchers perform under different contexts of the game, and so on and so forth. When you look at it, all of those conditions I just described, we see differences in rational ways. The reason we can get to that is because we're using that common measuring stick. Any other questions? Okay, I'm going to go ahead and keep moving then.
Sorry.
Oh, great.
There were some technical difficulties on our end. Madeline just asked in the chat box, tell me about that box. Is bottom left better than bottom right?
Good question. So on our model, let's see, where's my location? There it is. Okay, so the answer is no. Our model is symmetric about both the horizontal as well as the vertical through the strike zone.
Hi, this is Lewis. Can you hear me, Dr. Wilson?
Yes, I can.
Okay. Did you do any correlations or any look at the data as how would either predict or trail ERA on a monthly basis versus through an entire season?
Good question. Looking at it, so you probably saw that you're anticipating where I'm going here.
Yeah.
I do show, let's see. Yeah, so I do show, let's see, where's the ERA? Yeah,
Wow.
right here.
Yeah.
This particular slide is ERA, and these are basically quality of pitch values. So as we're getting larger, the ERA is going down. And this data is simply over whole seasons.
Mm-hmm.
So when you go monthly, the correlation decreases. There's more noise.
Mm-hmm. How about over a career? Can you see, as pitchers, as we all age, or do you see pitchers having resurgence over their careers?
It really depends on the pitcher.
Mm-hmm.
Yeah. The ERA itself, like if you take ERA in 2018, try to predict ERA in 2019, they're actually not highly correlated. And so that is tricky to do, but it turns out using QOP, it depends on the pitcher. Some it does better than others.
Mm-hmm.
In particular, oh, go ahead.
I apologize. I interrupted you mid-sentence. Please continue. I'm sorry.
I was simply going to say that the correlation is stronger for the extremes. So if they are, if they have a higher ERA, then that's going to tend to correlate with a lower QOP, and then the particularly low ERA with the higher QOP. When it's more near the average, it's not very correlated at all. There's a lot of different factors in those ranges.
Mm-hmm. And I noticed you mentioned the Astros, and have you taken your model and interpolated? There's rough data about the actual trash can being hit, at Minute Maid Park, and there's a frequency distribution of that data. Have you factored that in, or is it more that their pitchers were so precise anyway that they were able to navigate this anyway? Was it more, did the cheating really have that much of an effect, or was it a combination of cheating and exceptionally talented pitching?
Great question. You're anticipating one of the things I want to get to. So do you mind if I defer that question?
No, let's go. Let's keep going.
Till that portion?
Sure.
Okay, great.
Sure.
Thank you.
Okay, one last question that was in the chat before we move on, if you mind, Dr. Wilson, was Madeline was asking, where is the batter in that box that you were showing earlier?
Okay, the batter, if I run back up there. So this middle black line is the strike zone. And so the batter is going to be on either side of the strike zone, and then the bat's roughly going through, whatever section they're aiming for the ball at.
Okay, awesome. Thank you. Please continue.
You bet. Okay, thank you. Really appreciate the questions. I think that helps all of us here. So I don't have time to show everything here. I'm just going to do some highlights. This is a pretty compelling graph. When we discovered this, we were tipped off to it by one of the Major League Baseball analysts, said to look for this. What you see on the x-axis is the batting order. So there's 9 players on the field, 1, 2, 3, 4, 5, 6, 7, 8, 9, and they're going to go in batting order 1 through 9. And this is their first time through. Stronger 2 batters are up first, followed by some weaker batters, and then a strong one at the end. That's a pretty standard thing, lineup in MLB. These are average quality of pitch averages for the league. I forget which year this is. And you can see that once you move to the second time through the order, a fatigue factor sets in. You have the same basic pattern, but it's a lower overall average. And again, for the third time through the order, we again see that fatigue factor. Let's see. This one is pretty important. We did not hone in on this until last year. And what you see here is for the lower QOP values, 0 to 3, as you get towards 3, the vertical axis is home run proportion. So as you get towards 3, there's an increase in the home runs. Whereas once you go past 3, as the quality of pitch goes up, the home run proportion decreases. This is for 2019 data. The reason for this is the pitches over here are going to be a lot of times outside the strike zone, not as desirable for the batters to even be hitting. And so once they start getting towards the 3, that's more in the range where they feel they can get a good hit on it. So there's 2 different behaviors in the quality of pitch value. But we do see an important relationship between quality of pitch and home runs. Again, these are averaged. If you were to take this over a single pitcher or a month or something, then there's going to be more variability. Okay, this is seasonal. So these are years, averages for years. And again, we see this, this upward trend for below 3. We see the downward trend for above 3. Okay, looked at that one. This is one of the predictions that we've been able to develop for ERA. In the interest of time, I'm gonna keep moving here. Let's go down. Okay, so here's one that we did. I just was at the SABRE conference this last weekend, and we talked to a company that's working on injury prevention, and they were very interested in this kind of result. Can we detect a decline in pitch quality that could have determined alternate pitch selection and or influenced managerial decisions? Okay, so this player, Hyujin Ryu, here's his miles per hour. This is averaged by 10 pitches in 2014. At the time I did this, I hadn't constructed a function to take the average of an at-bat. So I was just using 10 pitches to try to track kind of performance. We since developed an at-bat, but this is the earlier work. And here's, these are off-speed pitches, which is the pitches that have curve in them as opposed to the fastballs. And this is the quality of pitch average on his off-speed pitches. And they were steady. Now, for a particular game, he had a steady, these are individual pitches now, average miles per hour by 1. For this particular game on May 26th, he was steady, actually even maybe increasing a little bit on miles per hour, whereas his quality of pitch value was in decline. Okay, And for this particular game, he was pitching a no-hitter, and it broke here at the end. Okay. Now okay. I mentioned injury prevention on the last one. That was a no-hitter. This one, injury prevention. Josh Beckett, 2014. He threw a career-ending pitch that resulted in career-ending injury on August 3rd. And his miles per hour was not in significant decline, but his quality of pitch average was for his fastballs. So we have posed the question, could we use quality of pitch in-game analysis, or maybe during a season, to detect the potential onset of injury? We've not come up with a clear pattern that this is a cut and dried. There are cases like this where we do see things. So that's an area of current research. Let's see. Now I want to, okay. Let's home runs. In 2017, there was the historic home run record, and I just have a few headlines here. Some people suggest that MLB was intentionally juicing the ball or made manufacturing changes to result in more home runs. Lots of papers on this. Okay, and the first ones were referring to 2017 season. This is the 2019 season. And it was particular because the record of 2017 was broken by over 500 home runs. And so this has been a lot of talk for a number of years. So let me discuss this a little bit from a pitch quality perspective. I've put down here the home runs from 2008 to 2019. I've got the two records here in red. Here's a longer term graph going from 1900. Okay, so these are the two records. Now, what's notable is that the MLB commissioned a panel to study the ball for the 2017 season. This panel consisted of 10 scientists, two of whom were statisticians. One was Jim Albert from Bowling Green State University, and the head of the panel was Alan Nathan. He's a retired physics professor from University of Illinois. And the conclusion of the panel frustrated a lot of people. They concluded that, yes, the ball has changed. However, we can't explain the change. They knew that it was a reduced drag upon the ball, and that's all that they could tell. So this set off a lot of controversy. In their conclusions, they also stated that the only source of change was the ball. It did not have anything to do with the change in batting approaches, nor did it have to do with the pitching. So nevertheless, we wanted to look at the pitching and see if they might be wrong and pitching was a factor. So that's what we did. Here's the strike zone, and the strike zone consists of these zones here, 1 through 9. 11, 12, 13, 14 are outside the strike zone. There's more sophisticated models, but this is a common one, and we chose to use that in our research. Okay, now, in this graph, I've got the distribution of pitches by zone, and this is according to year. So we're just seeing how the proportion in the zones has changed over the years. And what really stands out is this is zones 11 through 14 at the high, that's outside the strike zone, and then 1 through 9 down here at the low. Okay, now what we wanted to do then was take a look at all 6 of our pitching components and see if we could detect any changes in the pitching components during 2017. We also then later did this for 2019, so I'm going to pay attention to both as we're going through. And keep in mind that in 2017, the home run was a record, quality of pitch was also record low. 2019, home run also was a record, and quality of pitch was also the new record low. So we suspected there was a relationship with quality and the components. We wanted to see what it was. With RISE, we're not seeing, these are control charts. Control charts are used in manufacturing. This is approximately a 3 standard deviation distance from the mean of each point in the process. So 3 standard deviations below is the LCL, 3 standard deviations above the mean, the upper control limit. Okay, nothing out of control here. Lateness of break, nothing out of control. Vertical break in 2017, without these 2 other points, that one was out of control. So that was a massive drop. And also horizontal break fell out of control in 2017, big drop. So vertical break and horizontal break were the targets for 2017. 2019, you see that horizontal break is also out of control. And then 2019, location, it goes wildly above the upper control line. Okay, velocity had been steadily ticking up all the way into 2017. Okay, so let's see. Now there's a lot here, so I just want to focus in on a couple of highlights. The conclusions that we came to after all the work was that in 2017, you see zones 7 and 8. I've set this up so it looks like the actual strike zone. This is the upper left, this is the middle, this is the lower right. So zones 7 and 8, which are going to be low and outside for a right-handed batter. Majority of the batters are right-handed. See the massive drop in the proportion of pitches going there, okay, from what they had been. So the pitchers are relocating these lower pitches up into zones 1, 2, and 3. That relocation resulted in a drop in vertical break. Okay. In 2019, zones 4 and zones 5, the dead center of the strike zone, you have these massive drops. And the biggest relocation is to zone 14, which I've got on the next page here, is look at that 20 to 21. So a full 1% of pitches were moving into this lower right-hand below the strike zone and close to the right-handed batter. So it's moving inside and down, which is harder to hit a home run from, theoretically, for these batters. That's the main discovery that we made. I won't detail it, but we ran logistic regression models that validated that analysis. So when we looked at the proportion of home runs in each zone by year, so this is not the proportion of pitches in each zone now, it's proportion of home runs. You can see that the lowest proportion of home runs are from outside the strike zone. And all these inside the strike zone, for 2019, they're all going up. To us, that was evidence that it didn't matter where you were locating, it was still going out. which meant that there's more than just the pitching and the locating. That's evidence for a ball effect. Okay. Zone 14, you can see, is also going up here. Only one of these, I think it was the zone 11, was not actually an increase when you zoom in on that. So even zone 14 was going up, which is indicative of ball. Yeah, there it is, home run proportion, zone 14. Okay, so we did some logistic regressions to validate that. And let me move on to, let's see, kind of covered that. Lewis had the question with the sign stealing. So I want to get to that, and then we can maybe chat on that a little bit. So just, probably, I don't know, a month ago or so, we started working on this sign stealing deal. So for those of you who aren't familiar with that, 2017, Houston Astros won the World Series. It later came out that they were using video technology to steal signs and relay them to their batters in game. The rule that they broke is not the stealing of signs. That's a baseball tradition. The rule that they broke was the use of technology in order to steal the signs and relay. So MLB has researched that, published an indictment of the team. The players aren't sanctioned, but upper management was. Once that came out, those upper management staff were fired by the Houston Astros. Boston Red Sox is currently under investigation. Okay, so we've started to look into this, and the initial thing that we noticed was if you compare home versus away games, home games is where the report says that the cheating occurred. The away games, that's not in the report that they cheated on the away games. So we focused in on detectable differences between home and away. We noticed that the quality of pitch average of the pitching that Houston Astros at home faced was below what they faced away in the years before 2017. However, in 2017 and after, it switched and they faced higher quality of pitch average. We've since been able to dig in and find a difference in correlation between the 6 Houston Astros batters that are known to have done the most sign stealing. Correlation between their swing rate and quality of pitch average faced that is different from the rest of the league. And that's as far as we've gotten right now. I'm going to leave it there for questions on the results portion. So Lewis, if you want to follow up, or anybody else.
Yeah, sure. The question that I have is, how effective was this for the 6 batters? And have you shared this with MLB?
Good question. We don't really talk to MLB much these days. We're more in conversation with sports journalists. And so we have some journalists that have made some inquiries with us on this matter. And simply due to time, we haven't gotten down to we haven't finished our full analysis on this. And as far as how much does it help the batters, I don't really have an opinion on that. We're just focusing on the effect of the sign stealing on the pitching.
Mm-hmm. Interesting. And so have you looked at the data set of the pitchers whose signs were stolen and their ERA in Minute Maid Park, Houston's home field, relative to being on the road? For example, Kershaw has got a pretty strong ERA in Dodger Stadium, but down there, at Minute Maid Park, the ERA is pretty poor. Have you been able to parse the data to validate that?
So that's one of the reasons why we think that there's going to be something there with quality of pitch average. And I just had a phone meeting with my colleague Wayne and my students this afternoon, actually. I was planning on doing some research on this weekend, but we got invited to be on a panel last minute at the conference. And so they wanted to talk about the automatic strike zone. So I wound up spending my time looking at automatic strike zone. So you're right in the zone of kind of where I want to get to, and I just haven't had time to yet.
Of course, everybody in LA wants you to look at the World Series data.
Yeah.
Right.
Yeah. Yes. Yeah.
Yeah. Interesting. Yeah, it'd be interesting to follow your research and see what you find there. What do you think? Do you have comparable data sets with the Red Sox and the influence there? Is there a inverse data relationship that you're showing here between 16, 17, 18 when they had the run to the World Series?
You're right on with where we're going. I've been I directed my students to kind of dig around, and I just haven't had the time to do it myself. And that's one of the things on our list. We haven't done that yet. What I told them to do is I said, I want to focus on the Astros and see if we can detect a pattern. And once we detect a pattern, we're going to make a prediction about the Red Sox and then check and see if our prediction is going to hold with them. So that's my approach for it. And that's probably going to happen in the next couple of weeks.
Yeah. The Aldous Chapman episode with Altuve, that would be just that at bat would make it a fascinating blog post because nobody can touch his pitches. I mean, he's Aldous Chapman, for everybody's reference, is like one of the leading pitchers in all of baseball for the Yankees. But yeah, fascinating. I mean, this is great. I want to take all your time, but look forward to your research and your publications, the data, and once COVID-19 runs its course, it'll be good to see everybody back on the field again.
Indeed.
Interesting.
Yeah. And if you want to follow us a little bit, at QOP Baseball is our Twitter handle, and so once we get something, then we'll send out something on that.
Great. Very good.
Yeah. Thanks. Great questions, Louis.
Thank you.
Cool. Yes, great questions. I noticed that Madeline was raising her hand in the participants list. Madeline, do you have a question?
Yes. Was back to where you were looking at the components of your measurement by year. Did you have enough data to actually reevaluate the model year by year, sort of thinking of it from a manufacturing or an application kind of thing, where you would sort of continuously be reevaluating that you have the right model?
Yeah. So There's over 700,000 pitches per year. And so there's a lot of pitches, and I've run this multiple regression model for each year. And this particular one is the 2019 model, and we do it by pitch type because the pitch types have different behaviors, and including with respect to home run hitting. So the results are similar year by year. I mean, there are changes, but and actually this is 2017. Excuse me. So yes, we have done that.
But you haven't changed it. You've just evaluated it. You think that you don't have enough data to say you would change it.
Oh, okay. So are you referring to the quality of pitch value
Right.
model? Oh,
Yeah,
okay, for
yeah,
that.
yeah. Sorry about that.
Yeah. So there's no doubt that it's an imperfect model. The greatest flaw that's been pointed out to us about it, which we completely agree, is with the changeup. Because in our model, the more speed, the better the pitch. And changeup pitch is a pitch that relies upon a slower speed. And so that goes against our model. One of the virtues of our model is it does not take into account context. At least it's a virtue in the way we're using it. Another virtue is that it doesn't require a pitch type to be labeled. So it simply takes the pitch trajectory on its own merit. And so we could incorporate a pitch type and then after the fact impose, okay, this pitch was this type and therefore bring that in. So in short, we could make a more complicated model, a more sophisticated one that perhaps might be able to give a greater accuracy in certain senses. However, we really like the context-free functionality of it, and it allows us to have this universal measuring stick. And so once you have the measuring stick, you just recognize that's how it is with changeups, and you can still use it fruitfully. And I'd like to add one thing at this point. If you go to our website, qopbaseball.com, there's a filter on there that you can go through all of our past data from 2008 up through current and access the averages for your favorite pitcher. You can search by date to get games or blocks of games. It's pretty versatile, and you can download that data into an Excel spreadsheet. And so it's a pretty nice tool that people have using quite a bit.
Are you using Shiny to do that?
I'm not. We have a technician who's developed the site and maintains the site.
Okay, thank you.
Yeah, you're welcome.
Awesome. So I just placed that link in the chat, and I don't see any other questions at the moment. Please continue.
Okay, great. So I'd like to move over to some scripts then. And I'm going to switch my, let's see, I'm going to stop sharing the screen and then switch over to my R. There it is. And these are the scripts that Alyssa posted. So if you wanted to download those and the 2 data files to follow along, that would be great, but it's certainly not necessary. And so I won't read through the things here. I will use the dplyr and the GG formula packages. And for the first one, I just want to show you, if you're following along, then let's go down here to row 56 and below. And I would recommend just maybe highlighting that whole block and running it. That will load the functions that I've written. And so I'll just go ahead and load those up. Okay. And so if you want to read some of my coding, the first one I'm going to do here is some old coding. And then the later one is some of my newer style. So plot QOP is a function that plots that heartbeat graph for the pitches. And I'm going to go ahead and do my my graph here. So I'm going to go ahead and run that one. And this is all pitches for the demo data. So let me comment on the data. The all 19 demo has got 748,000 pitches. That is the 2019 data file that I've downloaded from MLB. That's pretty much how it comes down to me. So you've got yourself a nice big data file there. The next file that's called demo is 1,000 observations. And that one has quality of pitch values calculated. However, because our quality of pitch model is proprietary and the patent is still pending, I've removed the indicators that give exactly how we got those values. So I just pulled out a random 1,000 from an unknown year and pulled out some of the variables there. So there's two of them. For this particular one, we're using the demo data. So there's 1,000 pitches, and it's not being discriminated by game or pitcher. So it's just 1,000 pitches. The window is 1, so that's every pitch. And we can run the next line, which gives a window of every 10 pitches. And so you can see that I've put some labeling in there. I've calculated a p-value for a simple linear regression line. And that's my style in the script if you want to read that one. Next one here, we're going to use dplyr. And if you want to have some fun, you could click the little hand thing and give me hands on how many people use dplyr. So I see Alyssa does. Okay, so load the library. For this first one, game link is the variable name that has the name of the game as well as the date. And I'm going to go ahead and let's view the big data file just so you can see that. I won't look at the whole thing, but you got your designation, and then there's a bunch of stuff in here that's not super useful. There's the time in Zulu. You got a couple timestamps. This is the release that they're showing, which is 50 feet away from the mound. They don't actually give you the release point. This is the speed at start, the speed at end, top of the strike zone, bottom of the strike zone. This PX and PZ are the measured coordinates of the ball crossing the strike zone plane. X0 through Z0, these are the initial coordinates of the ball at 50 feet. This is the initial velocity of the ball, 3 dimensions, and the initial acceleration. It's these 9 points that we use to decompose the trajectory, and I could go so on and so forth. So there's a lot there in the data. The game link is 1, and so if we go ahead and review that, let's look at the head of X. That's giving me the top six, the first six games. These are ordered here, and the number of pitches that occurred in each of those games. So I always like to look at things that way. Then let's go through here, and I just took a filter of all of Clayton Kershaw's pitches in 2019. Okay, so if I run a table on his pitch types, I'll just run that. It's kind of my old school there. Changeup, curveball, four-seam fastball, slider, number of pitches on each. Okay, this is not my classification. This comes in the data, and it's known to be imperfect, but it is it's pretty good. Now I'm going to use dplyr, the group by function, and summarize. Notice the chaining operator there. One nice command, it used to take me longer than that. I can generate my miles per hour and the number of pitches, same info as came from the table command before. So that's pretty slick. And then demo 3, let's see. This is something, they asked us to be on this panel for the automatic strike zone. So I chose to show these scripts to you guys that I cooked up this last weekend. Wrote a function called plot.zone4. So first off, I'm going to take a filter, and I want just this particular game. Let's see, I don't remember off the top of my head why that game, so let's check the plot. Okay. Oh yes, I remember this game. I ran a search that calculated, let's take a look at this graph, and let me go ahead and export it. And Alyssa, tell me if this is visible.
Yep, it's visible so far.
Okay, great. So I just enlarged it a little bit there. All right, so the blue dots inside the yellow is a strike zone. Those are called strikes. So you see some called strikes going outside the strike zone. Those are errors. And then the red dots are balls. Those are the called balls. And so there's no called errors on the balls. This particular game, if you take the number of called strike errors and divide it by the total number of called strikes plus total number of called balls, it's 21.8%, I think. So that's pretty bad. The average called strike error rate is 5% in 2019. Turns out when I did the calculation, it was 2.8% in 2008. So it's creeped up over the years.
Question.
Yes.
The error is in the data, or the error was in the umpire?
That's a good question. So these called strikes are called by the umpire. And so this is the most egregious game. I'm going to get off of that game because I'm not trying to run down the umpire. I was actually very, very impressed at the job the umpires do looking at this data. I was asked by the moderator to generate that graph for that game. He also asked for this particular graph where there was a particular player in the dugout and the manager that were both kicked out of the game because there was yelling that came out of the dugout because of 2 called strikes in a row. And so we watched the footage and saw it. But anyway, I can get all that with my plot.zone. So this last one, I'm going to camp on that one. This one is a World Series game in 2019. And some people have complained about the umpire performance when I generated this graph. And so I want to answer your question, Madeline, from this one. You see that the only mistakes are right on the strike zone edge. And in the discussion of should Major League Baseball move to an automatic strike zone or not, this strike zone has a little a potential error on it. The points have error on them. And so the process that I'm using here itself has some error. So the numbers that I'm reporting are just based on the data that I've received, but they're not accounting for possible errors. So this guy's caught in some flack, but looking at his performance, I mean, the guy's doing a great job. So anyway, those are some thoughts. Let's open it up for questions on R scripts, and you want to ask about process on R or anything like that. You might want to look at my plot.zone4. If you go down into the scripts, then let's see. Okay, it relies upon a plot.zone3 function, which does I think it creates. Let's see that. It constructs the strike zone itself. This is a standardized strike zone. I had to solve a math problem because every time a batter goes up, the strike zone depends upon a measurement on their back and where their kneecap is at. And so every single stance, they're kind of up and down, strike zone's different. So in order to create a graph, then you have to come up with standardization so that you map every point to a relative position to a fixed standardized strike zone. And so I performed those calculations inside of here. That was actually the hardest part of the whole thing, was to figure that part out. So I coded that up, and then it's relatively easy to come in and use GG formula to come and just throw these points on top of that graph. And that's basically what it does. So, but once you write that, then I have a tool in my hand that I can then go and you guys could give me a game and I could look it up and then boom, plot the thing. So that's where the fun comes.
Nice, that's impressive. I'm not seeing any questions in the chat right now.
Okay, well, that's what I have. Thank you so much for the invitation.
Yeah, no problem. Thank you so much for coming and speaking. That was amazing. That was a fascinating talk. Okay, I'm going to share my screen once again.
Thank you all for your attention and great questions.
Oh, I see something in the chat. Oh, never mind. Oh, yes, Madeline?
Yeah. So your 2019 data, the all data file has all the raw data if someone wanted to do their own modeling.
That's right. If you go into the MLB system and get their data, then that's what it would look like. And so if you wanted to develop your own quality of pitch, if you wanted to decode that the trajectory, the simple way that they give to decode it is with it's just a simple physics equation that takes those 9 points and basically maps the parabola in I guess it's a curve in 3 dimensions. Very simple equation to do. We use a system of differential equations that's a little bit more sophisticated in order to account for the drag and Magnus force on the ball and get a more accurate trajectory. But it's all right there in that data. And then you've got the miles per hour, you've got the games, you got the pitchers, the batters, all the counts. You can track the full game just from the data that's in that file.
So is that, you have a special relationship with MLB to get that data?
No, that's freely available. Yeah, if the way we get it is inside of R, there's a package called MLB Game Day. And so it's capital M, capital L, capital B, and then Game Day. You can load up that package, and I forget the name of the function, but there's a function that you can just put the dates in that you want, and it'll literally just pull that data down for you and stick it right into R.
So it just strikes me as a fascinating data set to use. One of the things that I do is give workshops coaching undergraduate students for DataFest, which of course fizzled out this year. But one of the challenges is for them to get a data set that isn't immediately obvious what the variables are, and they have to like learn the context and you know, develop some things. For example, the physics of that, it might be leaning too much into on the male side of things, but it's still a fascinating data set. Appreciate your talk. Thank you.
You're welcome.
Thank you again. So moving forward, just want to take the time to acknowledge our co-organizers. I'm Alyssa Columbus. I'm the founder of this group. I founded it about 2 years ago, and we've usually met at UC Irvine, sometimes at People Space, but we're grateful to be able to meet virtually too. I'd also like to acknowledge Linda and Madeline who are on the call, and then Stacy and Liliana couldn't join us, but we value their contributions as well. So we're always looking for new volunteers and co-organizers, and we'd love if you could help us grow in 2020. We'd love to hear your ideas for events and workshops, new networking events, virtual networking events. Yeah, if you could help out at meetings or like spread the word about Our Ladies Irvine, we'd be very grateful. And then finally, you can find us online in a lot of places. Our website is www.ourladiesirvine.org. We'd love if you can add yourself to our MailChimp distribution list there, which is under the contact section. If you scroll all the way to the bottom of the website, which isn't that long, maybe takes like 2 seconds, you can add yourself there. You can also add yourself to the directory of Our Ladies worldwide at ourladies.org/directory. Again, that's the worldwide directory. That's not just us. You can follow our chapter on Twitter at Our Ladies Irvine, similarly with the global Our Ladies organization. Yeah, since all of you have joined this call today, you're all on our meetup, so thank you for joining that meetup. You can chat with Our Ladies all around the globe and all the different Our Ladies chapters, like the 100+ Our Ladies chapters there, and even the Our Ladies remote chapter at the Our Ladies community Slack. We also have a SoCal Rug Slack where there's our group, there's LA, our user groups and Our Ladies groups, there's San Diego and Riverside. Yeah, it's wonderful to be able to network with people in our closer vicinity. And then we also have a GitHub where we post all of our documents. And then finally, you can always contact us at our email, irvine@ourladies.org. So with that, if anyone has any questions, please type them in the chat. Otherwise, thank you so much for taking the time out of your Tuesday night to come and listen to Lewis and Dr. Wilson and myself present. We hope you enjoyed our meeting, and we're looking forward to having another meeting soon. Thank you.
Alyssa, I know in the chat that Amy Chen posted the link for on Thursday, LAR is having an online meeting. Just bring that to attention. Scroll
yeah, that's wonderful.
The chats there and show that link.
Yeah, be sure to attend their meetup on Thursday too. Thank you. I see another thing in the chat.
Thanks, Alyssa. Nicely done.
Thank you, Alyssa. This was great.
No problem. Thank you.
Hi, Linda.
Hi, Madeline.